Good morning, everyone. My name is Dr. R. Sudhir Babu, Associate Professor, EC Department, G. Pullareddy Engineering College, Autonomous, Kurnool. Yeah. The last class we have discussed about the fundamental definition and the different areas of applications of image processing in the different bands of electromagnetic spectrum. So today we'll see the next concept in image processing, that is the fundamental steps in image processing. Okay, so if you want to design any image processing application, so you are supposed to understand what are the steps that so one might follow. Yeah. So if you want to process an image, first, so you are supposed to have an image. So image acquisition is the foremost step in designing any image processing application. So for the fundamental step or the first step in designing any image processing application is image acquisition. So image acquisition is nothing but acquiring or getting or collecting the images. So in order to acquire images, of course, we need image acquisition devices. Example, the simple cameras. So depending on the application at hand, so you'll be using, or the people will be using different types of cameras in order to acquire the images. And some image acquisition devices may not produce digital images directly. So in such cases, so we need a backup system so that will convert the analog or continuous images into digital images, so that these acquired images can be processed by using digital computer. So the fundamental step in designing any image processing application is image acquisition. So once you got acquired images, the next step that one would follow is image enhancement. Image enhancement. So by definition, image enhancement is a process of improving the appearance of the image. So image enhancement techniques assumes that input image is a degraded image, or it's not a good quality image. So image enhancement techniques applies some sort of image enhancement algorithms and generates an output image that is far better than the original or input image, so that the enhanced image will be used for further processing in the complete image processing application. So after image acquisition, the next step that one would follow will be the image enhancement. So this is nothing but the improving the appearance of the image. The image enhancement is basically, it is a completely a subjective phenomena. So I'll give the basic difference between the subjective phenomena and the next phenomena that we discuss in one of the image processing image processing steps. The next step in image enhancement is image restoration. So image restoration is, again, it is also a process of improving the appearance of the image. So there is a fundamental difference between image enhancement and image restoration. So as I was mentioning, image enhancement is a subjective process, whereas the image restoration is a objective process. So now I need to give the fundamental difference between subjective process and objective process. Yeah. So let us take image enhancement process, which is a subjective process. So enhancement is nothing but the improving the appearance of the image. Right. So we'll be using the various types of image enhancement algorithms or methods or procedures to improve the appearance of the image. Let us take method 1 and method 2. So method 1 takes input image and process it and produces output image. So input image 1 that process the operations on the input and produces the enhanced version of the image. Assume it is a output image 1. So method 2 also takes the same input 1, and process it and produces output image 2. Yeah. So in the case of subjective process, and if you want to decide whether method 1 is producing good output or method 2 is producing good output, so what we do is we just place output 1 and output 2 side by side, and we'll compare the result. So based on the direct human evaluations or the side-by-side comparison of output 1 and the output 2 will decide whether the method 1 is producing better output or method 2 is producing better output. So this is what is called a subjective procedure. In the case of subjective procedures, so the evaluation results will be compared by the side-by-side comparison of the outputs based on only the human observations, and so they won't use any the mathematical proofs in order to validate whether method 1 is producing good output or method 2 is producing good output. Now coming to the objective process, right? So objective process is also, so here I said the image restoration process is an objective process. So objective process is a one in which, so if you want to evaluate the various methods, whether method 1 or method 2 or method n is producing a better version of the output, so what we do is, again, the method 1, so we'll take input 1 and it produces output 1. Okay, so let us take it is output A for input 1, and so method 2, it takes the same input and it is producing output B. Right, in the case of objective process, so if you want to evaluate whether method 1 is producing good output or method 2 is producing good output, we use the standard mathematical procedures like signal to noise ratio or mean square error criteria. Mean square error, so we'll take output 1, so output A and input, and we'll calculate mean square error. Similarly, we'll take output B and the input 1, and we'll calculate the MSR, the mean square error. Similarly, we can also calculate signal to noise ratio of input image and the corresponding output image. And the method that produces the better or a good or better SNR and low MSR, mean square error, will be considered as a good the restoration procedure. So if method 1 got a high SNR and the method 1 got low MSR compared to method 2, so in this case method 1 would be a good procedure in order to improve the appearance of the image. This is how objective evaluations will be done. So this is the fundamental difference between the image enhancement, which is a subjective process, and the image restoration, which is a objective process. So in both the cases, the image enhancement and the image restorations work to improve the appearance of the image. And if you take so simple examples of enhancement procedures and restoration procedures where they will be used. If you take image enhancement example, if input is a dark image, so we'll apply image enhancement technique and we'll create a high contrast image, or I simply we'll create a high contrast or a brighter version of the image. or if the input image is a low contrast image. So here image enhancement technique that would be applied could be a simple contrast stretching operations. Contrast stretching is one of the image enhancement techniques, so that so improve the appearance of the image, considering input is a dark image and the output is a high contrast image. Similarly, if the input image is a low contrast image, apply image enhancement technique like histogram equalization, and get a high contrast image. So this is how. So these are the simple examples of image enhancement. So here, in these cases, the results are procedures like contrast stretching and histogram equalization procedures. They are basically evaluated by side-by-side comparison of their corresponding outputs, which is a completely a subjective process. So results will be evaluated by only the human observers, whereas the image restoration, which is also used to improve the appearance of the image. So for example, input image is a blur image. Input image is a blur image. So now we'll apply some kind of restoration procedures like deblurring filters, and produce a sharp image. Right. So we may use the sum, and so we can use different types of the n number of deblurring filters. There are n number of deblurring filters available in the literature. Deblurring filters are available in the literature. So if you want to decide which filter is good for creating a sharp image, so what we do is we use the concepts of signal to noise ratio and mean square error criteria. So we'll calculate these two parameters for each case. For filter 1, filter 2, filter 3, we'll calculate SNR and MSR. And the filter that produces better SNR and the better mean square error will be considered as a good deblurring filter for a particular application. So this is a completely objective process where the methods are here the deblurring filters. The response of the deblurring filters will be evaluated by the standard mathematical parameters. So this is what is called the objective procedure. Right. Yeah. So the steps that we were discussing in image enhancement, image processing is image acquisition, image enhancement, and image restoration. And then the next step that could be color image processing. Color image processing. So color image processing basically deals with color images. As far as the syllabus is concerned, so I'll be concentrating the 90% of our discussion. So I'll be discussing all image enhancement procedures. The input image is a monochrome or black and white image. Input image is a black and white or monochrome. So the most of our discussion, the input image is considered to be a monochrome, but so we'll also be discussing how all these image enhancement, all these image processing techniques will be applied for color image also. Yes, yeah, the techniques that we use for image enhancement of monochrome or black and white images are equally suitable for enhancing color images, but with a little the computational burden. So when you come to the point of color image processing, we'll see so how the color image can be processed by using the techniques that we have already discussed in the context of monochrome or black and white images. Right. So after color image processing, the things which will go in image processing is wavelets and multi-resolution analysis. Yeah. Hope the most of you know. So what is the purpose of Fourier transform? The Fourier transform is basically used to convert a time domain sequence or signal into the frequency domain. And of course, you might be knowing what are the advantages of converting a time domain sequence into frequency domain, but we don't get into the details of so what are the advantages of getting or go into frequency domain from time domain. But here the main thing is the tool, the mathematical tool that is used to convert a time domain sequence into frequency domain. So our image is a two-dimensional signal. Image is a 2D signal. So in order to translate a 2D signal from the time domain, so it is also called spatial domain to frequency domain. So we need to apply two-dimensional Fourier transform. So a two-dimensional Fourier transform will be helpful to convert a time domain or a spatial domain image into the frequency domain. Right. So there is another tool which will help to translate a spatial domain image into frequency domain is your wavelets. So wavelets helps us to translate images from the time domain to spatial. But there is a fundamental difference between the Fourier transform and this wavelet transform. So here the wavelet transform has a added advantage that so the wavelet transforms gives you the direct relationship between the pixel in spatial domain and the corresponding frequency domain. So wavelet gives you the relationship between the pixel, a particular pixel in the spatial domain, and how it will appear in the frequency domain. Whereas in the case of Fourier transform, the entire image will be translated into the frequency domain, but there will not be a direct relationship between pixel and the corresponding frequency component. Right. And of course, using Fourier transform, we can do a lot of things in the frequency domain of the 2D image. But so if you want to analyze image further, or if you want to analyze the image in depth in the frequency domain, the people will go for wavelet transforms. Right. So the wavelet transforms is again the one of the important steps in image processing, so which will be very helpful in analyzing and processing the images in frequency domain. Yep. Yeah. The next thing is image compression. Image compression. So image compression is one of the important steps in designing the most of the image processing applications. Image compression is nothing but reducing amount of storage. Reducing amount of storage required to the save images in the computer. Right. The storage is nothing but memory. So image compression basically deals with reducing amount of memory required to store an image in a digital computer. Right. And of course, so with the recent technologies, there is a tremendous growth in the memory technologies. So the huge quantities of memories are available for the users at very cheaper prices. But so along with the storage requirement, so we need to reduce transmission requirements also along with the storage requirements. So image compression helps in reducing transmission requirements. So transmission requirements in the sense the channel bandwidth. So I will get into all these two details in depth. So when we start discussion on the image compression. So at this point, so image compression is again one of the important steps that will be used in image enhancement. Yep. The next step in image enhancement is morphological image processing. Yeah. See, all the steps that I discussed so far, from image acquisition to the image compression, the inputs and outputs are basically images. Now we are getting into a domain where the input is an image and the output is basically the attributes or features of the image. So the morphological image processing deals with the tools that will actually extract the some of the features of the image, so which will be helpful in deciding the shapes of the objects. The morphological image processing deals with the tools that will extract some image features which will be helpful to describe the shapes of the objects in the image. Yeah. The shape description will be a crucial step in some applications where the application demands the shape of the image to be known or identified. So the morphological image processing helps in extracting the attributes of the image, so which will be helpful to identify the shapes of the objects in the image. The next is image segmentation. Image segmentation is one of the very important and a very tough step in image enhancement or image processing application design. So image segmentation basically deals with separating or dividing the multiple objects from the scene. So multiple objects in the scene means if you capture any image, for example, if you capture a image of a classroom, the classroom contains students, benches, lights, fans, etc. So depending on the application at hand, for example, if the application is a automatic attendance system where the system has to identify all faces of the students which were sitting in the classroom and the mark the attendance automatically. So no human intervention. Whenever the class begins and the system captures the image of a class and it automatically identifies all the faces of the students and it marks the attendance for the particular student. If he is present, and if he is not present in the classroom, so he will be marked absent. In such case, the system has to separate the different objects like students, benches, lights, and any other things which are available in the scene. So image segmentation process actually deals with the tools which will be helpful in separating the multiple objects in the image or scene, right? And the success or failure of the application depends on the very rugged image segmentation algorithm. So in the sense, if we have designed very sophisticated image segmentation algorithm, so which will separate or extract the objects smoothly from the image, then these the separated objects will be helpful in further processing in the complete image processing application. If the objects are not segmented properly, then so this segmented data may not be suitable for further steps in the image processing complete application. So the success or failure of image processing application, the purely depends on image segmentation algorithm. So it is a very crucial step in designing any image processing application. Yeah. So the next step which always follows image segmentation is representation and description. representation and description. So the representation and description step always follows image segmentation. The output of the image segmentation process is a raw pixel data. And this pixel data may represent, this pixel data may be the pixels of boundary of object, or pixels within the object, or region of the object. So output of segmentation is a raw pixel data, which will represent either boundaries or regions. Right. So now, so we need to decide whether this raw pixel data has to be considered or represented as a boundary pixels or region pixels, depending on the application at hand. So if application is basically identifying the shapes of the objects, then the representation of the segmented output as the boundary pixels is a fair one. And if application demands analyzing internal features of the objects like color, texture, etc., in that case, so representation of the output of the segmentation process as a region pixel would be a correct option. So representation helps whether to consider the pixel data which is coming out of the segmentation process as boundary pixels or region pixels. Right. So the description. So we need to describe whether this pixel data represents, the description actually helps in, the description actually gives the information obtained from the segmentation process, which will be helpful to identify the shapes of the objects, or the descriptors or the description helps in identifying the shapes of the objects. Okay, the step that always follows representation and description is object recognition. Yes. So object recognition basically deals with the tools, so which will actually label or assign the labels for the objects. Based on the information provided by the descriptors. Based on the information provided by the descriptors. Yeah, so descriptor provides information about the shapes of the objects based on the segmented data. Now, taking that information as input, object recognition is able to assign labels. Labels are nothing but names for the objects. For example, in a class of, in an image of a class, so there will be students, and there will be tables, there will be fans, there will be lights, and so on. So the information provided by the descriptors helps to give names for the student objects as students, and table objects as tables, and sorry, fans as fans, and lights as lights. So the object recognition is a process where the process assigns the labels or names for the objects which were segmented in the segmentation process, right? So that helps in further recognizing the objects. Yeah, so these are all the basic or the fundamental steps which will be used in designing of any image processing application. And if you see, so all these blocks are basically floating, but they will not be floating in a real system. So all these blocks or all these steps will be connected to one central system called knowledge base. So it is also called database. Yeah. So if you want to design any image processing application, the database or knowledge base plays a crucial part. The crucial roles in the sense, right, if the application is, for example, a face detection system used for secure entry of employees of a manufacturing unit. Yeah, so a manufacturing unit needs a secure entry system based on the faces. So we can design a simple image processing system which will identify the faces of the employees entering into the facility, and once the employee is identified as a AG9 or it is a verified employee, then so the system has to allow this employee to enter into the premises by opening the doors, something like that. So in that case, so if you want to implement this application, or if you want to design this application, so what we need to have is, so there must be a database of authenticated or allowed the employees of the manufacturing unit. If the manufacturing unit has recruited, say, 1,000 employees, so all 1,000 employees faces of the 1,000 employees has to be stored in the database. When a particular employee comes and stands at the entrance of the unit, then the system has to capture the image, and so that is what is called image acquisition. And then so some image enhancement has to be carried out on that image just to improve the appearance of the image, so that so these images will be used, they will be used in a better way in the further processing in the image processing system. So image enhancement or even image restoration, if it is a dark image, we'll apply the image enhancement to get a high contrast image. If it is a blur image or a noisy image, we will be applying the image restoration techniques. Yeah, still if you are working, if the system allows color image processing, so we'll be capturing the color images and we'll applying all image enhancement algorithms on the color image itself, right? So we'll be doing all these processes, and then we will be doing what is called the segmentation, just to separate the only facial part of the person entering into the premises, and so representation and the description steps will be carried out, and finally object recognition will be done. Object recognition, so assigning the labels and performing some kind of matching algorithm, so that if the person trying to enter into the premises is available in the database, then the system will automatically revoke the door, and the person can enter into the system. So this is a simple system where it will be used in the used for security entry of the employees of a manufacturing unit by detecting the faces. Okay, so the knowledge base, the database should have the images of all 1,000 employees. So then only, so we can actually run the system, and we can implement the system and run the system, and we can deploy the system for real-time use. So knowledge base plays a crucial role in any image processing system design. So all these blocks will be interconnected to knowledge base or database. Right. So this is how we'll be designing the image processing system, and these are the fundamental steps in image processing. Right. So depending on the application, the what type of images we will be capturing will be different. For example, in the case of face detection system, so we'll be capturing the faces of the images. For example, if the image is a iris recognition system, in that case, images will be iris of the person. If the application is to grade like the fruits in a manufacture in a unit, in that case the image will be the pictures of the fruits which are coming on the industrial line and so on. So the image acquisition actually gets or acquires the image of the problem domain at hand. So depending on the problem domain, the images which are available in the database will vary. Okay, so these are the fundamental steps in image processing, and so we'll stop the class here, and we'll continue with the next topic in the next session. Thank you.